And touching on the second portion of the Unit 5 notes is going to be acids and bases, which is the reason we went through and actually hit into solutions. Acids and bases are going to be defined based on the way that they interact and what happens to them when they happen to be dissolved in water. No solid by itself is considered an acid or base. Being considered an acid or base does not occur until the object itself has been dissolved in water, and its behavior in water determines whether it is considered an acid or a base. Okay, so when we go through, when we go through and start looking at acids themselves, acids basically when they happen to dissolve into water produce hydrogen ions, which are going to be H+. You'll also see some textbooks say something about a hydronium ion, H3O+, and what that's saying is that there is a extra hydrogen going through and combining with the water molecule so that you have a positively charged ion. But essentially what we're talking about is acids themselves happen to be an H plus an element, so that's how we can go through and figure out the naming of it. If something has starts off with an H and then you see some other element, whether it be polyatomic or not, you generally have an acid. So our example here is HCl is going to be an acid. So that's how we can determine it by looking at the formula. And we know that when dissolved in water, acids are going to produce hydrogen ions. Bases, on the other hand, are generally formula-wise going to be seen as an element and ending in OH. So your example would be sodium hydroxide here, NaOH. So your base is always end in OH. And what a base does when it happens to be dissolved in water is it's going to produce hydroxide ions, otherwise known as OH negative ions. Okay, so your base is basically going to your base is essentially going to be the negatively charged OH that's getting produced, and your acid is going to be your H plus hydrogen ion that is being produced when it's in solution. And again, your acid starts with the H, your base will end with OH. So looking at what this H plus is, and we kind of talked about this, why are H plus ions referred to as H3 plus ions? It's because that for an acid to actually be in solution, it's got to be dissolved in water, and what happens is the H plus ion attaches to a water molecule producing that H3O plus. So if you happen to see the hydronium, please don't freak out. It basically means the same thing as saying that we've got the H plus ion. In either case, we're looking at the charge associated with the ion itself. The acid happens to have the positive charge, while the base has the negative charge being produced. Okay, so as the H plus increases, we know that H3O plus is also increasing, which is why you'll see these two changed or used interchangeably depending on who's discussing acids and bases. When we look at acids themselves, we know that they happen to have very specific properties. Acids go through and conduct electricity when they are in solution. So again, it's got to be in solution to be considered an acid or base. So when it's in solution, they're going to conduct electricity very well because you have all those positively charged ions all over the place. Acids are going to be very corrosive. They're going to taste sour, and they're going to react with metals. Okay, and hopefully you should be able to pick up the fact that this guy right here is an acid because of your initial hydrogen. Okay. Now, examples of acids, we see a lot of foods, your citric acid in orange juice, your lactic acid in milk, your acetic acid in vinegar, your nitric acid, which are in fertilizers, and folic acids in green vegetables. Okay, many of your acids happen to be, when we look at our scale, you're going to be things that happen to be in food. Now, once we get to the stronger acids, they cease being editable, but a lot of your weaker acids are organic. Okay, bases, on the other hand, happen to form negative OH ions in solution, or OH minus ions in solution. And again, our properties for that guy, or for the bases, they happen to be slippery, and that will kind of make sense in the way we kind of remember that is most of your examples for bases happen to be cleaners. Bleach, baking soda, ammonia, soap. Most cleaners tend to be basic, and that should kind of help you out with the whole slippery thing. They as well conduct electricity in solution because you have a whole bunch of negatively charged ions, and as you have an ion, it's going to conduct electricity when it's in solution. Bases taste very bitter, and they're also corrosive. And you should be able to again go through and look at this equation and tell me that this is a base because it ends in OH. Okay? So how do we measure acids and bases? Well, we do it by using the pH of a solution. We kind of have a whole pH scale that ranges from 0 to 14. Okay? pH is just going to be a measure of how many H plus ions we have. The more H plus ions you have, the more acidic something is, because as we increase H plus, we are increasing the acid level. And as we go through and we do that, we are basically lowering the pH, because as you're going to notice over here, the 0 to 6 range happens to be acids. So this portion right here are the acids. Okay. On the other hand, and we'll go through and we'll switch up to, I forget yellow, let's go with blue. The fewer the H plus ions, so if we decrease the H plus ions, we are going to decrease the acidic level. And what that's going to do is that's going to cause for a higher pH, because 8 through 14 happen to indicate bases. Okay? So the pH is basically measuring how many H plus ions we have in that solution, and as we add more H plus ions, we are becoming more acidic, and your pH continues to lower. So the very, very, very most, or the very maximum amount of H plus ions we can have are in the very strongest acids down here at pH of 0 or 0.1 or 0.01, stuff like that. The very lowest amount of H plus ions we can have are going to be up here at your very, very, very strong bases, up at 14. Okay? The closer you are to 7, the weaker the acid or base is going to be. So baking soda is going to be a weaker base than soap would be, because it's closer to 7 in pH. And we kind of hit on this already, with 7 being neutral, and that's a very, very key thing. The further away you get from 7, the stronger the acid or the stronger the base is going to be. So something that has a pH of 1 is going to be a much stronger acid than something that has a pH of 5. Or something that has a pH of 11 is going to be a much stronger base than something that has a pH of 8, because the further you get away, the stronger you get. Okay. And as we work our way down, there are generally ways that we can go through and determine what strength an acid or base is without actually going through and touching or tasting, because those would be terrible when we're trying to figure out the strength of acids or bases. We can use things called litmus paper as an indicator. And indicators are going to be things that allow us to visually tell the pH of a given substance. So when we take litmus paper and dip it into a solution, it will change color to indicate what that pH is. If we happen to have this yellow litmus paper, if it turns red, it happens to be an acid. If it turns blue, it happens to be a base. And if it stays yellow, it happens to be neutral. Okay? Now, this is where we get kind of cool, is there are certain things in nature, certain flowers, that'll actually go through and act as natural indicators, where depending on the pH of the soil, a flower will either end up growing as red or blue. And so you can see multiple different indicators, and if we talked a little more in depth about this, you can get very, very specific indicators that will only change a certain color if they happen to be, let's say, between 3.2 and 3.6. Anything outside of that range will not change colors. So in this class, we're going to use very, very broad litmus paper as indicators, but you could get very specific with it if you wanted to. And one of the fun things about acid-base reactions themselves is the idea of neutralization. When you take an equal strength acid and an equal strength base, the acidic and basic properties are going to cancel out, and your remaining ion is basically going to form a salt and water. So what we're looking at here is when you mix a equal strength acid with an equal strength base, for instance, you take your hydrochloric acid, which we know is an acid because it's starting with the hydrogen, and your calcium hydroxide, which you know is a base because it's ending with your OH. Okay? When you mix them together, you're going to get your positively charged hydrogen and your negatively charged hydroxide forming a water. Well, that means that our positively charged ion, the cation, is going to be the calcium here, and it's going to combine with your negatively charged ion, the chlorine, to form CaCl2, calcium chloride, and that's going to end up being a salt. So we've talked about before when we did the types of reactions that it doesn't have to be NaCl to be a salt. If you get water in conjunction with anything that's not carbon dioxide, that thing's most likely going to be a salt in the terms of this unit. Okay? And if we happen to go through and have a strong acid mixed with a weak base, your resulting solution is going to be a weaker base, so it's going to take it back towards your neutrality of 7. On the opposite end, if I have to go through and mix a very strong base with a weak acid, we're going to get that returned back to our neutral solution again, or towards the neutral direction, having a weaker base as a product there. Okay, and this is just an idea of some common salts we have. So just because you don't recognize the salt doesn't mean it doesn't exist. Okay, so your big key here is if you happen to see water as the final product and you don't happen to see carbon dioxide as the other product, you should know that whatever this thing is that's not water will end up being a salt. Anyways, we'll go through and we'll talk acid bases a little more in class, but that should give you a brief overview.